Please encourage me to create new videos. Please like, share and subscribe to my YouTube channel. Thanks for watching. Explain the concept of synchronized blocks in Java. In Java, synchronized blocks are used to control access to critical sections of code to ensure that only one thread can execute a particular block of code on a given object at a particular time. A critical section in a program is a segment of code that contains shared resources like variables and data structures that must not be concurrently accessed by more than one thread at a time. Without proper synchronization, critical sections can lead to data corruption, inconsistent program states, and other unpredictable behaviors. This point is very important. Suppose if we have two objects, assuming name as object 1 and object 2, and we have two threads, assuming name as thread 1 and thread 2. If thread 1 has acquired the lock on object 1, then thread 2 has to wait until thread 1 releases the lock on object 1. But thread 2 can acquire the lock on object 2 as it is the different object. How synchronized block work? Step 1 is intrinsic lock, or we can say monitor. Every object in Java has an intrinsic lock, also called a monitor. When a thread invokes a synchronized block, it automatically acquires the intrinsic lock associated with the object. Second step is lock acquisition. If another thread already holds the lock on a particular object, the current thread is blocked and placed into a waiting state until the lock is released on the particular object. Step 3 is execution. Once the thread acquires the lock, or we can say monitor lock, it executes the synchronized block. During this time, no other thread can enter any synchronized block of same object. This point is very important. Suppose we have a counter class that has two synchronized blocks in increment method and getCount method. If we have two objects, assuming name as object 1 and object 2, and we have two threads, assuming name as thread 1 and thread 2. If thread 1 has acquired the lock on object 1 and is executing synchronized block in increment method, then thread 2 cannot execute any synchronized block or synchronized method until thread 1 releases the lock on object 1. But thread 2 can acquire the lock on object 2 and can execute any synchronized block or method as it is the different object. Step 4 is lock release. After the synchronized block completes its execution, whether normally or by throwing an exception, the thread releases the lock on a particular object. In the later part of this video, I will show you the code example of using the synchronized block. This is the code snippet of synchronized block. We have created synchronized block in increment method and getCount method. I am going to run the program having 4 threads, and you can see the output of the final count. Expected count is 40,000 and it will be same all the times when we run the program due to synchronization. High level steps for creating synchronized block code example are: Step 1. Create the counter class. Counter class contains one class level variable, or we can say instance variable named count. we will be incrementing count variable with the help of increment method. And for retrieving value of count variable, we will use getCount method. We will be creating synchronized block in both of these methods, increment method and getCount method. When you use synchronized with this keyword, this means the current instance or current object of the class. Only one thread can hold the lock on this current instance or current object at a time, and other threads trying to enter any synchronized block or synchronized method on the same object or instance will be blocked until the lock is released. This is the corresponding code of step 1. We have counter class and we are going to create the object of this counter class, and this object will be shared by 4 threads. This is the count instance variable and it is the main candidate for race condition. This instance variable will be updated by multiple threads. This is the increment method that will be called by multiple threads to update the value of count instance variable. In this line, we will get the name of currently running thread assigned by the JVM. This is the beginning of synchronized block. This block will ensure that only one thread can enter this block and can execute the code at a particular time. This will ensure thread safety and prevent race conditions, or we can say unexpected results. In this line, we will be incrementing the value of count instance variable. By using the getCount method, we will be retrieving the current value of count instance variable. This is the beginning of synchronized block. This block will ensure that only one thread can enter this block and can execute the code at a particular time. This will ensure thread safety and prevent race conditions, or we can say unexpected results. Step 2. Define the task. Create the counter task that implements the runnable interface. This counter task accepts the counter class object in its constructor. We will be incrementing a counter class variable, or we can say instance variable named count. Each thread will increment the value of count variable by 10,000 in counter task. This is the corresponding code of step 2. We have created counter task class that implements the runnable interface. This class defines the task that will be performed on the counter class object. This is the counter class reference variable. This is the constructor of counter task class that accepts counter class object. This is the definition of run method that contains logic for incrementing the counter object. We are incrementing the counter object by calling the increment method. All the 4 threads in our example will be updating the shared counter object. When we start the 4 threads, the control will go to the run method. Step 3. Starting the threads and passing the counter task as the argument. Create the 4 threads and pass the counter task as the argument to these 4 threads. This counter task further contains the counter object as an argument. All the 4 threads will be operating on the shared counter object. Wait for all the 4 threads to complete and check the final output of count instance variable. This is the main class where we are going to create the counter class object that will be shared by 4 threads. I will explain each line of code step by step. This is the counter class object that will be shared by 4 threads. We have created 4 threads and passed the counter task as an argument to these 4 threads. Each counter task contains the shared counter object. Here we are starting all the 4 threads by calling the start method on each thread. Here we are waiting for all the 4 threads to complete by using the join method. Join method causes the program to wait until thread on which it is called completes its execution before proceeding to next line of code. This block of code will catch any exception that occurs while executing the above lines of code. This line will display the final count of shared counter object that contains count instance variable. The value of count instance variable is same all the times when we run the program due to synchronization. You can see the output in the console. Value of count instance variable is 40,000, which is the expected output. This is the code snippet of synchronized block. We have created synchronized block in increment method and get count method. I am going to run the program having 4 threads and you can see the output of the final count. Expected count is 40,000 and it will be same all the times when we run the program due to synchronization. Each thread is expected to increase the counter by 10,000. Final value of shared counter object should be 40,000, which is the expected sum of increments of all the 4 threads. As we have implemented synchronization at block level, the final count will always be 40,000. The expected result will be same all the times. Due to synchronization, the threads will be getting executed in organized manner and they will not be interfering with each other. For better understanding, please download the source code from GitHub repository. I have provided the link in the description section of this video. Please encourage me to create new videos. Please like, share and subscribe to my YouTube channel. Thanks for watching.